All right, so this is the kind of questions that you'll see about chapter 7 stuff, more or less. This is definitely the harder side of those kinds of questions, so you won't really see anything beyond this when exam time comes around in a couple weeks. A week? A couple weeks?
When is it?
I was just going to ask. Let's see. You know, I've got Blackboard pulled up here, so.
24.
Is it the 24th? But that's not the schedule. The week of the 24th, so the 25th?
Yeah.
Okay. So that is 1 week from Tuesday, so like a week and a half away. Okay, so let's talk about these. Some of these required some different types of skills from chapter 7. So the first one, you had to be able to complete the reaction, which means you had to recognize what type of reaction it is also. And then you had to balance it as well. So what are the products of this reaction? And how do you know? Anybody feel good about this one? Yeah?
CO2 and H2O.
Yeah, how do you know that?
I just figured it was like a combustion.
Right. Anytime you see a hydrocarbon reacting with oxygen, that's an example of a combustion reaction. The only thing that's going to form is carbon dioxide and water all the time. Doesn't matter what kind of hydrocarbon you're starting with, you're going to make carbon dioxide and water. So once you know that, then you can balance it. Like that. And that's a combustion reaction. Identifying the type of reaction was an extra credit point for these. Because that's, even though we've done a lot with that, it's technically not in the list of stuff that you're supposed to be able to do. So we just do that for extra credit. Okay, ammonia reacts with hydrochloric acid. Ammonia is given, NH3. Hydrochloric acid is HCl. Forms ammonium chloride. Balanced? It is balanced, as is. What kind of a reaction is that?
Combination.
Combination, yeah. You've got two things combining to make one. So that's called a combination reaction. Aluminum metal and iron oxide react. Iron 3 oxide. To form aluminum oxide and iron metal. That is not balanced, but it's pretty easy to balance like that. And what kind of a reaction is that? Single replacement, right? Yeah, because there's one thing by itself and then a compound, and then they switch places. Which of these, if you had to guess, which of these is most clearly a redox reaction? This wasn't part of the quiz, but what do you think? A is a redox reaction, but we don't usually recognize it that way because of what we've talked about, but you're right, it is a redox reaction. But C is, how did you know C, or how did you see?
There's two on their own.
Yeah, whenever we see elements on their own, and actually you can see that in A also because it's got oxygen on its own. So anytime you see a reaction that has some element on its own that becomes a compound, that's a good indication that there's redox chemistry going on. Because that means that when it's by itself, it's 0. And so when it's in a compound, it's got to be something other than 0. All right. So on to a reaction problem here. I gave you the balanced equation. You have to figure out the calculation to produce, what is it? How many grams of NH3 are produced from 5.24 grams of CaCN2? So we start with 5.24 grams of this. And we want to know how much of this is produced. So this is one of those standard, what we call a stoichiometry problem, where we just go from grams to moles, moles to moles, moles to grams, and figure out what we've got. So in this case, we're going to go grams of CaCN2. So something up here. We're going to convert that to moles. Okay. Then to moles of NH3. And then to grams of NH3. All right. We fill in the middle one, the mole to mole ratio from the equation. So that's 2 to 1. And then the others are from the molar masses. So the molar mass of CaCN2 is going to be 40 for calcium, plus 12 for carbon, plus 2 N's is 28. That's 80. And NH3 is 14 plus 3 is 7, or 17.
Do you not need to be super exact about the decimal places?
Right. It's kind of up to you. I mean, yes, you do, like, there's rules about it, but for our purposes, we're just going to say whatever. It's fine. Okay, so let's calculate that out and see what we get. 5.24 divided by 80 times 2 times 17, 2.23 grams. And if you got something a little bit different because of how you rounded, that's fine. It should be close enough. And then finally, the last one, when hydrogen and oxygen gases react, how many moles of oxygen are required to react with 2 moles of hydrogen? So hydrogen gas and oxygen gas. We've done this reaction quite a bit. What does it form? Water. Yep, H2O. And to balance that, we need a 2 in front of the hydrogen and a 2 in front of the water. So if we have 2 moles of hydrogen, how much oxygen do we need? 1, because they react in a 2 to 1 ratio. So 2.0 moles of hydrogen means we need 1.0 mole of oxygen. And that's as easy as that one is. If that were a more difficult number, you'd have to do the molar ratio. That is, figure out how many of this to how many of this, and calculate it that way. So, any questions about that? You can do these kinds of problems? Maybe, sometimes? All right. That was quiz 5. We're almost halfway through, right? This is week 8, I think. So you're half done. Good job. Okay, the other thing I want to do today, if we look at our schedule, notice we're pretty much on track here. Finishing up gases this week. We actually finished up gases on Tuesday, and because there's not that much to talk about, and then we had those demonstrations in lab, and we'll talk about solutions next week. So I thought today would be a good time to go back to some of those equation problems, practice them, look at some different variations, and try to see where things are good and where things are not so good with your understanding of that. Even though we're only halfway through, we've actually done a good chunk of the work already. We've got basically 4 more chapters to go, which is not too bad since we've already done 6 or something. There's 5 more labs, one of which is kind of more like a mini lab, so like 4.5 labs to go. So we're getting close. 2 more exams.
So are we going to have a month where we don't have labs?
Not exactly, because exams are on lab days, so we'll have 2 more lab days taken up with exam 2 and exam 3. The very last exam day is checkout and like final exam review. And so that's the 3 labs that we don't do. And then we'll miss one, or we won't miss one for Thanksgiving because we still have Thanksgiving. But we will probably, something weird will happen in those couple of weeks because most of the classes miss lab that week. So I'll keep you posted on what's going on. I'm not sure what they're doing with the schedule exactly yet. Okay, so if we go to Blackboard, in the notes folder, I've put this equation practice sheet, and this is just a collection of problems from an online homework thing, but that people have found helpful in the past. It's also nice because I can post the answers that way pretty easily. So you can use this for practice. It's a lot of problems. It's a huge document. But this is usually one of those things in the semester that people really have some trouble with. So there's a lot of practice so you can really get comfortable with that stuff. And that's what we're going to pull most of the stuff from today. All right, so they look like this. One thing we haven't really talked about so much is, well, a couple things. One is moles of compounds, and the other is kind of different ways to express chemical reactions. So if we have something like this, take a look at this one right up here. Identify the coefficients in the reaction. We've got some different colored balls representing compounds, because that is what compounds are. How do we balance an equation like that if we don't have the subscripts and stuff that we're used to? What do you think is going on there? What would the coefficients be in that reaction? Give it a try. See if you can figure out what those different colors mean and how you would balance a reaction that's written that way instead of in the regular symbols that we're used to. So what numbers you come up with? Come up with some numbers? What numbers would you put in there to balance that? Anybody? Yeah.
1, 2, and 2.
1, 2, 2. Does that work? Yeah, let's check. So we should really check this just like we do any other ones, right? That gives us 2 pinks to 2 reds on the left, but I've got 2 pinks and 4 reds on the right. Right? So probably this should change to 4. Is that better? Yeah. And what kind of a reaction is that? Combination, yeah. 2 things going into 1. We don't even know what elements those are, but would you guess that that's a redox reaction? You're nodding your head? Yeah, why? Yeah, whatever those things are, the molecules on the left or the things on the left are representing individual separate elements. So the 2 pinks together might be something like O2, and then the red one by itself could be some other element. And so those coming together means that there's got to be something going on with electrons that's going to change oxidation states. So that's probably a redox reaction. Okay. Let's move on to some of the calculation type things. So here's another one that we should be able to do. If you're told this reaction is a double replacement, and even if you're not, you can recognize it as such, what are the products? So can you complete and balance the equation that's listed there? What do you have to do here first as we go through it? How do you find those compounds on the other side? Yeah, you've got to switch the metals and, well, don't switch both of them because you'll end up with the same thing, but switch the metals, switch the partners so that metals and the metals and nonmetals, or the cations and anions, end up with the opposite partners. Now, what do you have to watch out for when you do that? You know? Always, when you're doing that, always watch out for the charges. You have to readjust the ratios of the cations and anions in each new compound because they might not fit. You can't just say, oh, K2S, so the K2 goes with the NO3 too. It doesn't work like that necessarily. It might sometimes, but it doesn't always work like that. So you have to readjust based on the charges. What's the charge of potassium? +1. There's 2 of them for the sulfide, but the charge is +1. And what's the charge of nitrate? -1. So when you switch partners and put the potassium with the nitrate, what you get is KNO3, not K2NO3 2. Yeah, when we balance it, we'll have to do that to adjust for it, yeah. And then the other one is PBS. In this case, lead is +2 and sulfur is -2. So those go like that. Now it's not balanced, so to balance it, we would put a 2 here.
Why did you say that we don't include the 2 for K and why did you say we don't include the 2?
Because we have to build the correct compound formula from potassium and nitrate based on the charges. Potassium's +1, nitrate's -1, as always. So when those form a compound together, you only use one of each. So that's one tricky thing with this and the single replacements also. When you're switching partners, you have to readjust the ratios accordingly and then balance the equation. You can't just take the subscripts and mash them together. Let's try another one. Some of these are getting a little weird. Okay, I don't even know if this is going to show up right. Let's see if we can do this based on molecular shapes like this. So in this case, I believe the big green, what is the color look around here? The little ones are H, the big green ones are Cl, and the little yellow ones are F. And they're all gases. Can you write an equation for that reaction? So what are the reactants, and then what are the products, and then balance. We got an equation for that one? I think this is one in homework too. What's one of the reactants? HCl, yep. What else? Fluorine, F2. And so then the products are HF and Cl2. And that's how we balance it. What kind of a reaction is that?
Single replacement.
Single replacement, yeah. Good. Okay, one thing we haven't looked at as much, we've focused on the moles to grams and grams to all that kind of stuff. So oops, let's look at this one. Barium chloride and sodium sulfate react according to the following equation. How many moles of barium sulfate are produced from 0.1 mole of barium chloride? So this equation is already balanced for you. What do you think? Is this one we can just kind of figure out by looking at it, or should we write down some mole to mole factors? Yeah, I mean, really either way. You can always write down the multiple factors, or if you can see it, great. This one, I think, is a little bit easier because the coefficients are mostly 1, 1, 1, 1, and 2. And that usually helps us a little bit. So if we have 0.1 of these, how many of these are we going to make? That's moles. Sorry. 0.1 moles of these. How many moles of that? Just 0.1, because it's 1 to 1. So that makes it nice.
How are you getting 1.1 mole?
That's what the question says. So it's saying if you have 0.1 moles of this, how many of this are you going to make? So it should be the same. Okay, what about this one? We can cut off the end. We know what it's trying to say. How many moles of oxygen gas can 5 moles of hydrogen peroxide produce? So in this case, we may want to, you could probably maybe figure it out just by looking at it, but we might be helpful to write some mole to mole factors, and it'll be helpful for if we have more complicated numbers in the future anyway. So 5 moles, we start with what we're given, 5 moles of hydrogen peroxide. And then we write a mole to mole factor, kind of like that middle of our other equation. And then we pull the numbers right from the equation. So 1 of these for 2 of these. And 5 divided by 2 is 2.5. Good so far? Yeah? Okay. Oh, these come up in the homework too. Just we might as well look at them. Choose the mole-mole factors for the equation. Meaning, it's just saying exactly what we've been doing, but wording it in a little bit different way. So which is correct here? The bottom one? Yeah, because the equation tells us that the 2 goes with the Al, the 3 goes with the Cl2. And so those stay together in those factors. And then that's what we use in the calculations. let's oops. Let's take a look at these. Now we'll look at what we get when we start using some little bit weirder numbers that kind of require us to do some of those factors. So using that equation above, how many moles of carbon are needed to react with 0.490 moles of sulfur dioxide? See if you can figure that one out. All right. Did you get something like this? The equation tells us there's 5 of these for 2 of these. So we'll go 0.490 times 5 divided by 2 gives us 1.23 moles of carbon. Is that what you got? Great. So these, remember, you can go anywhere in the equation you want with these things. You start with whatever they give you. As long as you know one number and you've got a balanced equation, you can get all of the other ones. All right. It asks some more. You can work on that if you want to keep practicing there. What if we get into the grams now? Let's see. I want to do this one where we have to actually find the. Let's just start on the page. I'll just write it. Silver nitrate reacts with sodium chloride. Reacts with sodium chloride. How much silver chloride how much AgCl, silver chloride, is produced from 100 milligrams of silver nitrate? So I gave you one hint here. Silver is one of the weird transition metals that only has one charge. So it doesn't get the numbers, but we didn't really talk about that. So I gave you the hint of what the charge is on silver. So what's the charge on silver? Close.
+1.
Yeah, it's +1 because the hint I gave you is I wrote AgCl is a product. We know Cl is -1, so silver has to be +1. I didn't tell you what the other product is, so you have to try to figure out what that is. Write the balanced equation and see if you can solve the question that's asked.
You want moles or grams?
Grams. Sorry, that should have been clear. So if you haven't gotten the equation, it's this. So then that means the rest of the calculation. Now, what are you going to do with the milligrams? You can change it to grams. there is another option. I'm sorry if this confuses anyone. You cannot listen, but the other way to do it is to use millimoles instead of moles, and just kind of leave it in milligrams. Now, because I asked for the answer in grams, it ultimately doesn't matter, and you have to do a conversion anyway. But if the answer is in milligrams and the start is in milligrams, you can just kind of ignore the fact that it's milligrams and do it all the same, as long as it keeps the same unit. But for purposes of not confusing everyone, let's just go with convert to grams. So 100 milligrams is 0.100 grams. You can also, if you want, skip this mole to mole step in this reaction. Why is that? They're all ones, so everything's 1 to 1 to 1, so we don't need to do that. But if you're used to it, you might as well keep it the same way. Okay, let's put in our numbers. Silver nitrate. Oh, I could show you another fun trick, by the way. You can't use this in the exam, but for homework, it's helpful. There's a site called Wolfram Alpha. Has anybody ever used it before? People are nodding their heads. Yeah, it's a good way to cheat on math homework and stuff too. But it actually does a really nice job for chemistry. If you just type in something like silver nitrate, it will just come right up. I didn't even have to hit enter yet, and I'll get the formula, the molar mass, some information about it, that kind of stuff. If you go like this, you can find all kinds of stuff about it. But there's our molar mass that we want. It's about 170. Yeah. It'll also go the other direction. So if you type in, like you don't know what something's called in your homework and you don't know what the name of that is, you can type in AgNO3. And it will usually figure out that if you use like capital and lowercase letters for the elements, it'll figure out you're talking about a chemical compound, and it'll give you the same information. So you know that's silver nitrate and so on. Okay, so that's 1 to 1. We can do the same thing for silver chloride, but that's just 2, so it's not quite so bad. Let's call that 143. Should probably check if I'm right on that one. Yeah, 143. Okay. I guess as long as that thing's up, it's 0.1 times 170, or divided by 170, sorry. 3 is 0.084. Know what you got? Hopefully, maybe, possibly. Yeah.
Is it fine if you round your grams, like I got 169 and 143?
Yeah, so you got something close, but not exactly the same thing?
It ended up being the same, but
yeah.
Like, it's not.
It'll always be close enough. I'm trying to think if that's true, but yeah, I mean, if you're within small rounding like that, it should always be close enough. And if the only time I can think where that becomes an issue is in something like multiple choice questions, if the choices are really close together. But I would see that and say, well, those choices are too close together, so they can't be right or something, or somebody would catch it during the exam or something. I don't think it would be an issue. Okay. So with our last couple minutes, a couple things you should know about this. So first of all, with these types of questions, As you can see, the calculation part is always the same. You just have to know if they're asking for moles or grams or whatever. And a lot of the exam type questions will give you some information, so you only have to do that part. But there will also always be questions that have this kind of whole thing. And what screws people up a lot is just writing down the compounds. So you may want to go back to chapter 6 and just keep practicing on writing those compounds from the names, because if you don't write the compounds right, the equation doesn't come out right, everything else gets messed up too. So that's a big part of it. The other thing is when you do this on an exam or a quiz, make sure you show all your work. I mean, you don't have to. If you want to just write the answer, write the answer. But if you show your whole calculation and I can see, oh, this is all exactly right, but you said silver nitrate was AgNO2 instead of AgNO3, you're still going to get basically all the points. I may take a point off or something depending on how many points the question is worth. But if you just write down the wrong answer, there's nothing I can really do for you. So it helps if you write the whole thing out so that if something does go wrong, you know. All right, so Lab Tuesday. We'll have another quiz on Thursday over kind of like another chance at this stuff and the gases stuff. There's not much to talk about with gases, so it'll mostly be this kind of thing again. Kind of like a second chance from this quiz. And then the exam will be the week after that, so there will be no quiz that week. And have a good weekend. Tuesday.